All right, in this video, we want to basically solve this optimization problem over here. We have an equilateral triangle prism that has a volume of 400 centimeter cube, and we need to find the dimensions that will maximize the surface area. So let's just start by drawing this out. So we have this equilateral triangle over there, and then just turn it into a prism. And we want to basically minimize the surface area of this prism over here. We know that the volume is 400 centimeter cube. So the volume of a triangular prism is just the area of the front, which is base times height over 2 times the width over there. But to make things a bit easier in this question, what you want to do is you want to define the base over here as 2b, and then the height can just be h, and then the width will just be the width. And the reason we do this is because eventually we're going to use the Pythagorean theorem. So if we define the base as 2b, then half the base over here will just be b, and then we won't have to work with fractions for the rest of the questions. If you define the base as b, that would become b over 2, and then you'd have a lot of fractions in your Pythagorean theorem. So just to make the solution a lot easier, we define the base as 2b, and then half the base will just be b. So now let's come up with our formulas for this equation. I'll start by just filling out this volume formula, but I'll fill it in terms of these specific dimensions over here. So it's actually going to be the base is 2b, height is still h divided by 2, and width is still w. And then we can just simplify this. So these twos can cancel. The volume is just bhw. And that's our first formula over there. We know that the volume can be replaced with 400, so I'll do that next. So 400 equals bhw. And now what I want to do is I want to come up with a second equation for this question over here. Now I know there's three variables over here, so I have to come up with three equations in total. So for the second equation, I'm going to do the Pythagorean theorem on that right triangle over there. So since this over here is 2b and this is an equilateral triangle, this hypotenuse here also has to be 2b. So I have 2b square equals h square plus b square. And then 2b squared just simplifies to 4b squared equals h squared plus b squared. And I can move this and combine it on this side. So 3b squared equals to h squared. And then I can just isolate my h over here. So h equals square root of 3b squared, or you could put an exponent of half, whichever method works either way. So now that I've isolated the height over here as square root of 3b squared, I'm just going to sub that in for the height over here in this equation. So 400 equals b times square root 3b squared times w. Okay, so now I've reduced this equation over here down to just two variables instead of three, which is really good. So now I can come up with my surface area equation. So the area of this shape over here will be the area of the front. The area of the front is just 2b times h divided by 2, plus the area of the back, which will be the exact same, base times height over 2. Then plus the area of the left side over here, which is just w times 2b. Plus the area of the side opposite that, which would also be W times 2B plus the area of the bottom, which would again also be W times 2B. So let's just simplify this a bit. These twos cancel, so that's just BH. These twos cancel, it's also BH. Then this is just 2WB plus 2WB plus 2WB. Then I can combine like terms over here. That's just 2BH plus 6WB. Now I've already isolated H in this equation over here, so I can replace the H over here with that. So 2B square root 3B square. And then over here, I can isolate the W in this equation. So 400 over B times square root of 3B square equals W. And now I can replace the W here with that equation. So plus 6 bracket 400 over B root 3B square times B. So now I have the area equation just in terms of B, in terms of one variable. I can derive this, but before I derive it, I just want to simplify it first to make it a bit easier to derive. So the first simplification I can do is just cancel out these two B's, and then I can also do 6 times 400. So 6 times 400 is just 2400. Okay, so slightly simplified the equation over there. Now I could derive this over here straight away if I wanted to. I could use product rule here and I can move that to the top and derive it. Or something that's easier to do is I could make a common denominator and use quotient rule as well. Both ways you should get the same answer. But I'm just going to make a common denominator and do quotient rule. So I'm going to multiply the top and bottom here by square root of 3b squared. So this just becomes 2b times 3b squared, because the square root times the square will cancel out, plus 2400 divided by square root of 3b squared. And then I can multiply these two terms together over here. I'll write that up over here. So that's just 6b cubed plus 2400 divided by square root of 3b squared. This is as simplified as this can get. Now I'm going to just derive this with my quotient rule. So F equals 6b cubed plus 2400. G equals 3b squared to the power of half. F prime equals 18b squared. G prime equals half 3b squared times negative half times 6b, which can just half times 6b is just 3b, and then that's 3b squared to the negative half. And then let me put this in my quotient rule. So a prime equals f prime g minus g prime f, and then divided by g squared. So 3b squared to the power of half squared will just cancel off. So I'm just left with 3b squared on the bottom. So that's my quotient rule right over there. And now I just want to make this equal to 0 and solve it. So first things first, when I make it equal to 0, I'm just going to cross multiply this to the other side with a 0. That's just going to disappear completely. I'll just be left with the numerator. I'm just going to rewrite that, 18b squared, 3b squared to the power of half minus 3b. This term I'm going to move to the denominator to make the exponent negative. Then I have 6b cubed plus 2400. Next step is I'll just make common denominator over here. So I'll multiply the top and bottom here by 3b squared to the power of half. So 3b squared to the power of half times the same thing. That's just 3b squared. All right, the rest of it same. Now this just cross multiplies and disappears in the next step. I'll also expand out the top completely. So 18 times 3 is 54. Let me double check that in my calculator. Yep, 54 b to the power of 4 minus 18 b to the power of 4 plus, no, minus 2400 times 3. I think that's, yep, 7200 b. Combine like terms over there. So 54 minus 18 is 36 p to the power of 4 minus 7200 p. I can common factor over here. Common factor out 36b. I'm left with b cubed minus 200. So over here, my solution is just b equals to 0. Over here, it's b cubed minus 200 equals to 0. So b cubed equals 200. So b equals to cube root 200. So if your solution had to be an exact value, you'd leave b as that. But in this question, we're allowed to convert it into a decimal. So it's going to be 5.85. Using this value of b, we can find the other dimensions as well. We can find the actual base of this, which is 2b. I'll do that a bit later, but we can find the height by just subbing in the b over here. So square root of 3 times 5.85 squared. I'll just do that in my calculator. Square root 3, 5.85 squared is 10.13. And then to find the width of this object, I'll sub in my b over here. So it's just 400 over 5.85 times square root of that, which I know is just 10.13 because I calculated it right there. I'm not going to rewrite the whole calculation. I'll put this in my calculator. And I'll get 6.75 centimeters. So now that I've calculated everything, I can state all the dimensions of this triangular prism. So I know that the base is going to be, remember the base is not 5.85, the base is 2 times b. So the base is 2 times 5.85, which is 11.7 centimeters. The height of this prism is 10.13 centimeters. Calculated right there using the height formula. And then the width of this prism, gonna calculate it right there. It's 6.75 centimeters. And these are the dimensions that minimize the area of this equilateral triangular prism. Now, I know I didn't do any checks for this question, and I don't usually do checks because, generally speaking, these problems are designed such that the critical point that you get is automatically the answer for a question. But if you're in a class where you have to do your checks as well to make sure that the endpoints are not the minimums, you can always do that as well. I'm not going to explain that in this video though. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.